So I was actually a bit reluctant or worried about coming here to a Docker meetup to give a talk about Apache Camel. I'm happy that Ben convinced me anyway, so I'm here to talk about Camel and Kubernetes, and then a little bit of Docker. So I have actually been in Melbourne 15 years ago. That was before Docker and Camel, and I was actually a backpacker, as so many other people are. I was at the big stadium. I saw a football game, a real football game, you might say. It was Melbourne as the home team, but I couldn't really remember the away team, but I think it was Adelaide, if not mistaken. And we won, so we went in the city and celebrated that. It was also my first time up in one of these tall buildings as well. So this is also one of your tall buildings. You know, I'm from Denmark, and Sweden, we don't have tall buildings at all. Also, I had actually more hair back then, but also more fat. Now I have neither of that. And I also visited Albert Park back then. It was quite awesome because I'm actually into motor racing. So back then I walked the lap. Awesome. But this time I thought I could do better. So I ran it. Not one time, but 5 times.
That was yesterday we had good weather. Today was no good.
Absolutely. So here's a comparison with the horsepowers for Formula 1 car. It has about 1,000, and I have 1 Camel unit. So I could do my best lap in 23 minutes and so, and Schumacher and those guys can do it in 1.5 minutes. They complete 300 kilometers. Unfortunately, I can do less than 10% of that. But anyway, it's quite fun to do that. And maybe I'm from the northern hemisphere, so I may have been running in the wrong direction. Because while I was running, all the other people were running the other direction. So sorry for that. Maybe it was this confusing guy out there you can read about in the papers. Okay. A bit about myself. As Ben said, I am a software engineer from Red Hat. I've been working with Apache Camel as a primary developer for more than 8.5 years, so forgive me for that. When I say forgive that, there are some Camel users in here, so sorry for that. I have probably added some bugs to Camel that caused you some pain. I may also have fixed some stuff, so maybe that kind of evens it out. I wrote a book with Camel. I'm currently writing a single book, Camel in Action 2nd edition. It's not complete. It will be complete later this year. And actually, maybe that is a bit on purpose, because now I'm traveling. So I will actually be able to complete and update the book while I'm in different places of the planet. So I've been doing updates on the book in Europe. My co-author has been doing updates in Canada. And I will do updates here. I have been doing updates here in Australia. And next week I'll do in New Zealand. So it's truly a global book, international book. Okay, you don't want to hear more about Claus Ibsen, so let's get more serious. And for that, cheers. So, what is this talk? What is the key message of this talk? So, how many here are developers? How many are Java developers? Okay. Anyway. So this is a talk for developers. So if you are a system administrator or architect or boss or something, I'm a bit sorry, but there are some pluses and minuses with the different talks. So this is about developers that are using Java. And now we hear a lot about this containerized stuff, and it might be a bit daunting to get started using that. So this is more talk about how to get started with that. And all I do here today is demonstrating on a single laptop. Okay? But the first thing we can maybe get a bit scared is about these containers here, is how can we take our Java applications and now build them, package them as these container image. And how can we take these container images and run on a cluster like Kubernetes or OpenShift or one of the other 110 different variations that there is. Okay? So there's a lot. Also, when we get started as a developer to this new cloud world, there's a lot of new concepts to learn. I kind of like to picture this as this very famous iceberg, right? So what we're talking about today and what you're seeing here now, and the first concept you need to learn is only the top of the iceberg. Underneath, there's a lot more. I would say even more than traditionally. Beforehand, we have been a bit shielded from all these kind of things. As a traditional Java application developer, you've been building Java application and then hand it over to some operations people that will run it in app server kind of things. And that's it. You had sort of like a Java-based picture of the world. Now with containers, it's more Linux thing. And it's kind of like a bit scary because I'm actually working for Red Hat. It's the Linux company, so I'm supposed to know everything about Linux, but I have absolutely no clue what it is. Before that, I was, a consultant, an architect, and whatnot, and all we use are Windows computers and Microsoft Office and PowerPoints and all kinds of things, right? I have been doing a little bit on system administrator just by, if I really need to. I know about VI and these kind of things. And now, as part of Red Hat, we've all been using Mac computers. So now suddenly, all this networking thing and what Ben talks about, I really have to listen up. And I also feel that I'm getting a bit too old for all these kind of things, so it's a bit scary for me. So I'm saying, okay, if I can learn a bit about that and being a bit successful on the community thing, you guys can too. Again, there's a lot to learn. But I will talk about some of the most, let's say, concepts that are most important to know about Kubernetes and some of the first mistakes you may make when you start to run your Java application in such a cluster. And then at the end of the talk, there will be some words or information about referring to where you can find more information about all the other stuff that's under C. Okay, so when we get started on this container thing with Kubernetes or Docker Swarm, for example, or something like, not Swarm, but okay. Then it could be, okay, do I actually have to go to my boss and beg for him? Okay, I need a cluster or OpenShift, a Kubernetes cluster, and can you please set it up somewhere? Or I have to wait, somebody has to buy something, or if I start using this, I get a login, and then I start to, oh shit, whatever I do here, I maybe mess somebody and step on their toes, or maybe they can see how I can fuck it up totally. Why can't I just be over in my little corner here and just try my first baby steps by myself? And if something really goes wrong, I can just, smash the computer. Oh, okay. I can just turn it off and turn it on again, right? Everything is just running on my computer. And then after a while, I learn a little bit more about it. Okay, I can go back and say, yes, I know it, right? So what I'm doing here is running on a laptop. And I have to say, it used to be much harder. It still sometimes cannot work, especially if you take a laptop to a new Wi-Fi and all kind of things. So that's the most thing. But it used to be really worse. So I really hope, take a little drink. It should work. But there are ways to different run. You can run it on Kubernetes. The most famous one is called Minikube. Sort of like the first one that really worked. Then Red Hat looked at that. They say, oh, this is really awesome. We want to do it too. So we create Minishift. And then there was something called OpenShift CDK. There was an older version of it. It was really beep. But now it's better. So you can actually also use OpenShift CDK. It's improved a lot. But Minishift and Minikube are the dope for your local computer. And unfortunately, I have to admit, I'm actually running Minishift, so this is the sales thing you see. But Minishift and Minikube are similar, so I can actually use the Kubernetes command line instead, so to show it. I would have, if I had more time, switched over to a Minikube, but Red Hat told me in Sydney, Klaus, you must talk about OpenShift. So sorry, so the computer hasn't been changed since. I don't dare it. Anyway. To run Kubernetes or Minikube, you can find it on GitHub, download it there. There's an additional step you may want to do because Kubernetes comes with a command line shell called kubectl, kubectl. That's a separate download. But when you have the binaries, you're almost ready to go. The binaries are like an exe file on Windows. You just start it. But if you haven't installed Docker or any kind of virtualization software before, you need to install something, a hypervisor driver. If you're using Windows, you need to install something called Hyper-V. On Mac, it's called Xhive, and on Linux, it's called KVM or something. Yeah, I don't know so much about it. Oh shit, it's recorded. Oh yeah. And then type the start command, and it hopefully boot up. It outputs a lot, and it says, okay, you're ready to run. Minishift is similar thing. Download it, the binary, and you can start it. It comes out of the box with this command line thing, so there's one step less. I am starting, just showing the slide. I just say Minishift start, and it outputs a bit what it does. You need a Wi-Fi connection to the internet and start pulling down emails and so on and start it up. And all these things, you just hope it says success at the end and okay. But if something goes wrong here, you just stop the computer, leave it, and never come back. Or you have to figure out what the hell all this Linux stuff is, because you get all these kind of weird Linux errors. Okay, so this is my favorite thing. Can anybody see what that is? Yes, but it's not a. It's a special camel. What kind of camel is it? Yay! Oh, cheers for that. You got it. Australia is cool. Oh, I can just put my beer here, then I have a much shorter reach. So, yes, Lego, Denmark, the company from Lego, and so on. So let's build a little example. And as I said, I'm to environmental damage from Camel, so I always use Camel. Don't do that. Use Camel only sometimes when it makes sense. Anyway, I put the example on GitHub. And again, Red Hat, this is the sales thing, so it's actually called Minishift Hello. It's not Camel Hello or Minikube Hello. So, I actually have to do a little advertise for my company, the company I work for. I don't wear, usually a red T-shirt, but I do it today.
Running.
Oh, yes! They don't give me this for free. I have to fucking run 5 kilometers. And if you're a real attendee, they give you all kind of bags and kind of thing, a gift basket or something like that. But as an employee, you don't get anything. And the worst part was the run was 6 a.m. in the morning. I'm jet lagged, and we've been out drinking the day before, so I had 4 hours of sleep. But it was a fun thing to run in the morning in Boston. There are actually cars driving there as well. Okay, so going back to this little example, it's sort of like a very simple example. So it's hello, a hello service. So we have a service over here and a client here, and the client can call the service, and surprisingly, the service can give a response with something like a hello. Now, to make it a little more interesting, we use a dynamic response, where the response includes the host name where the service is running. Yeah, surprise, surprise. But why are we doing that? Of course, because we're going to run in a clustered environment, and when we run stuff in a clustered environment, it's much more dynamic. So we don't normally know always where it's running. The host name is not sort of like, okay, I'm going to run it on this server, foo, and on that server is called bar. No, it's all dynamic. So let's see, had the service tell us where it's running, and then we can see it. So you guys can see it's not just a sort of cheating example. So for Java, I am running these two Camel applications, so to speak, in 2 different runtimes. One is called Wi-Fi Swarm, and the other one is Spring Boot. It doesn't really matter, but just to use some popular runtimes. Otherwise, I won't be accepted as a speaker. They are more interesting, Spring Boot and Camel. So at least I can put Camel inside. So I have Camel both sides. So how many people have heard about or using Camel actually? Oh, that is 10 people for the recording. So Camel is good, but Well, here in Melbourne, it's rather new. For the workshop we had today, there was like maybe only one guy that was doing Camel. So there's definitely room for improvement in Australia. Anyway, so in Camel we have two small Camel applications. One is sort of using an HTTP engine called Untitled. You can actually use inside in Wi-Fi Swarm or Spring Boot and whatnot. So it's just saying from Untitled and do a message transformation. The other one is the client. So we want to call this hello service, but I don't want to click a button or something on my laptop. I just want to do it automatic. So we're using a timer. So just say from timer, call the HTTP endpoint, and then log it. Now you may think, why is it say HTTP4? Well, there's a different. This is because there are numerous Camel components, and there used to be one called HTTP. It's using an older library, and there's a newer version called HTTP4, which is using a next generation version of the library. This is 4.x. That's why it's called 4. It's not a new. It's not using HTTP4. We are still using 1.1 or 2.0. So these two applications you can easily build a Wi-Fi Swarm or Spring Boot application today by going to their website. They have this generator page or starter page where you can sort of select your dependencies and give your product names and click a button and download it. Camel is included in both of them. Here is the Wi-Fi Swarm, and here is the source code for that. So there's a Camel route where I have injected using CDI to an endpoint and a bean. The endpoint is using that HTTP Undertow servlet, and the Camel route is just saying from Undertow, call a message bean with the hello. So the bean is the guy where we're going to say, hello, I am from, and then the host name. Now, to include the host name, I have a little function, from inet address until get local host name to get that one. Okay, that's it. That's two Java classes. For creating the client that is using Spring Boot to call the service, you can do the same. Go to the website, choose Camel, click, click, click. And we have a zip file, you unzip that, and we change some few source code. We add a Camel route. This is just a timer. Every 2 seconds, call the HTTP and log it. That's it. Now, as a Java developer, we all knew that, whether or not we are using Camel. So what we are talking about now is that how can you, as a Java developer, take any Java project and get that built as a Docker image? Because that is the first step to this new Docker and Kubernetes world. And this is not as easy as it may sound. Now, a very popular build tool in the Java world is Maven. So what I'm showing you here is using Maven. So what we can do is to use a Maven plugin from the called Fabricate Maven plugin that has this functionality out of the box. So this is what you're going to use. And to use that product in your Java project, you just add it as a plugin. And this is the group ID, artifact ID, and the version you're going to use. Then we can, from the command line, type Maven fabricate build, and it will build your Java project as a Docker image. Now, that plugin is able to detect your cluster, whether it's a Kubernetes cluster or OpenShift cluster. And this is where there's a difference between the two of them. Now, with a Kubernetes cluster, a vanilla Kubernetes cluster, I may say, there is no, let's say, build support for building containers. You have to come with an existing container, and then you can run that in the cluster. Whereas OpenShift comes out of the box with sort of like a build server included. So you can actually tell OpenShift, this is my Java project, go and build it for me inside the cluster. So it goes and kicks off Jenkins and can do all the kind of things. There are two different. The Fabricate Maven plugin is able to detect which one are you using and sort of adapt to that world. So the screenshot here is from OpenShift that uses this source to I build strategy, where it sort of streams the source. Okay, so if we are typing and running this build plugin, we have a Docker image. But are we ready to run that in the container, in the cluster? Not entirely. So on the slide, this is a big hint what is wrong. So when we have a service and a client I want to call a service without a cluster platform, a dynamic platform, in the old days, I may say, that we are used to sort of hard coding or externalizing host names for the service we're going to call. So we cannot use localhost anymore. We cannot call it foo server or bar server or all that kind of things. It's much more dynamic. We don't know where it really is. So this is the first problem as a Java developer you're going to hit when you start to run on a clustered platform. So localhost 8080 is not like usable anymore. So what do we need to do on a Kubernetes cluster? We need to use something called a Kubernetes service. So over here where we host the service, we need to expose that as a Kubernetes service. Okay? So what is a Kubernetes service? Well, it helps with this. So now imagine that you have your implementation of that service. It runs inside Kubernetes as something called a pod. How many knows about pod? Okay, so I have to say, if you're from Australia, everybody's supposed to raise your hand. So English is my second language or maybe third language, and I had no clue what the hell pod was. So I was thinking this is a process or object daemon or whatever kind of it is, until someone explained a bit what it was to me. So okay, we step back a bit. We know Docker is this, whale, Moby Dick whale kind of thing. So okay, there's an element somewhere. It's a big one. Even though it runs as a lightweight, process container thing. Ha ha ha. So, okay, so a pod is, as you Australian will know, is a group of whales, a pod of whales. Okay, that's what it is. So what it means in the Kubernetes world is that a pod is the minimum deployment unit where you can have a group of whales or a group of containers. Now, the group doesn't mean it has to be two or more. It can actually be a single person or a single container. So it can be one or many. Very often you will have only one, but sometimes you have multiple of them. And there are reasons for running multiple. I'm not going to talk as much about that, but there's something called a very famous pattern called sidecar, which you're going to hear about in the future at least. Anyway, so we have this pod of whales, which often is only one, but the platform is dynamic, so we can actually scale them. Now we have two pods that host this service, and we have the client over here. And now it gets confusing. What the fuck, there are two? I'm drunk or what the hell? No, there are just two. But which one should I call? Okay, I just call you, right? And I'll call you, or I'll call you. But now this one is dead, and this one is over here. Oh, what's going on? So to make sure I can always call the service, I am not going to bother about looking where the fuck you are, and then I'm just going to call a service, and then let the service figure out where the hell these pods are and call them. So we use this level of indirection. So Kubernetes service is a level of direction between the clients that are calling a service and the service, or the pods that has the service. It sits in between. Okay? So this magic cloud that sits in between, what is that actually? That's actually this is one of the most brilliant thing a very brilliant thing about Kubernetes. So cheers. So a service is very simple, but also very brilliant. It's just a virtual IP and port number for a network. But it's static. So when the service, that means as a client, if I need to call a service over here, I just need to get hold of that IP and port number one time. It's static. It means it never changes for the entire life cycle of that service, whereas everything else is dynamic. Even myself, I can die, and then somebody else creates me and boot me up and whatnot. But all these parts over here, they're dynamic. They can run on different nodes and whatnot, and you can scale them up and down. Doesn't matter. The client that is using and calling the service just has that static IP and port number, and you had needed only one time. That also means if calling a service is just IP and a port number, it means you don't need any special Kubernetes client library. For Java developers, there's no Kubernetes client jar file which you need to use, because it's just a virtual IP and a port number, and any programming language can do communication over the network. But how do we get this service IP and port number? That's the next question. So how do I get that as a client? So there are multiple ways with Kubernetes, and one of the earlier ones, the first one, was that Kubernetes allows you to look up any service using, this is also very brilliant, environmental variables. It sounds a bit crazy, but when Kubernetes starts a container, it will actually inject all the service names inside as environmental variables using this pattern with service host and service port, and then the name of the service in front of it. That means you can always look up any service using this pattern as environmental variables. That also means any programming language can do that. You don't need a Java library to do that. Okay? Awesome. Brilliant, simple, and so on. But also, Kubernetes allows you to discover service using DNS service naming, and this is sort of the default now out of the box and so on. This was, the early version. When I got started with Kubernetes, we were using environmental variables. And DNS was sort of the new thing, a bit scary, not as stable, and so on. But now it is. But this one, you still have it, and it works still. So in Camel, we have made it easy to call a service using these environmental variables, because we can refer to a service name using squirrely service : and then the name of the service. So instead of having localhost here, :8080, we just say this service : hello swarm. Hello swarm is the name of the service. And that's it. Now, you can also use DNS naming. And this is sort of like coming back to many years ago, because, or maybe you think it's an anti-pattern, because when we are building apps for the traditional application servers, they ever tell, and I was calling a service, and it was called foo, and they told me, no, you never hardcode anything in your programming. You have to externalize that, and we have like a properties file, or when you deploy something in WebSphere or whatever, there was sort of like a description, deployment description, there was a Word document, you follow that, and the operation guide type in something or something like that. So, and now with the the dynamic platform, we can hardcode things again. What the fuck is going on, right? So now it's getting even more crazy, because Ben and I, if Ben create a new service, awesome beer. Okay, Ben can tell Claus, okay, I'm creating a new service. I'm gonna name it awesome beer, and I can even choose the port number as well. So you can choose 1, 2, 3, 4. Then I know when awesome beer is deployed inside that cluster, I am calling a service called awesome beer, awesome name, and the port number is 1, 2, 3, 4. What the fuck? I can even hardcode everything now. That's kind of crazy, right? And if you're really, really clever, you may choose port 80 as the default if the service is HTTP based. Then I don't even know, I have to remember the port number. Anyway, so they are clever, those Google guys. Oh, I talked about beers, and they have to rush, right? So now we are ready to run our application in the cluster, because now we know that when we call a service, no longer localhost 8080. Well, guess what? If you really want to screw up people, you can call a service localhost. Okay, so now we're ready to run in the cluster, OpenShift or Kubernetes. But how do we do that? Well, again, it's not as hard. Yeah, okay, it's OpenShift advertised, but it could be Kubernetes. Again, we have this Maven plugin. Surprise, surprise, it has a goal called deploy. So you can actually take your product, Java-based product, and build and deploy it in the cluster, all running on your laptop. So a screenshot of how I'm doing that, fabricate, deploy, and it output on the console what's going on, and so on. We can do the same for the client. One thing to know is that the Maven plugin also has a goal called run. So this is, we wanted to make this plugin similar developer experience as if you're using plugins for running on Tomcat and Jetty and Spring Boot and JBoss and so on, because they have this kind of notion if you can run something, your application in the foreground. So this will do the same. So if you type fabricate run, it will actually deploy it in the cluster, even though it may run on the same computer, but it can also run on a real cluster. What it does is then keeping the shell open, tail the logs of the running parts, and presenting it on the shell here for you as if it were running in the foreground on your computer. So it's kind of simulate that. And then you can press Control Space or Control C to stop that one, and it will undeploy your application. But it gives you that same experience where you sort of feel like it's running in the foreground. Okay, so now we really need to boost, because now we see if the demo works. So let me first just a little more OpenShift advertised. You can type minishift console, and it comes with a web console out of the box. There's one for Kubernetes as well. The minishift has a bit better, stronger for developers, whereas the Kubernetes one is more for ops guys and infrastructure. But they can both look inside your cluster. So I have a bit of things already running here. So I have already deployed and running one of the pods which hosts the service, the Hello service. This is called Hello Swarm. That's why you see a circle here with one pod running. The client that is calling the service is not deployed yet. So this is what we're going to do in a moment. Now I want to, just from a browser, to call this service here, which I can do from this link here. And if I refresh that one, it says Hello Swarm, blah, blah. And this is the dynamic host name, Hello Swarm 16 something. That's the pod name. We're going to do a bit of a demo and running things and see something. And we're supposed to see this changes over time if I scale up and scale down and so on. So what we're going to do here is also, I can also call the service from my shell. So if I have a shell script, I can use curl to call that service. For example, here I do it 2 times per second. Right? So that's also possible, of course. That's not as interesting. So let's just go here and go to the client. So this is where I'm going to do a Maven fabric 8 deploy, if I can spell it. You usually can if you have not had 2 beers beforehand. So yeah, let's just quickly jump here and see the web console. This is actually where there's some of the things is the most fun, because the web console should live update and see what's going on. Now, oops, there comes something. There's a client here starting to deploy that one. It's light blue, which means that the pod is starting up, but it's not yet ready. So because it's using Java, and Java is not the fastest technology in the planet, even though I have a 16 gig of memory and all that kind of things, and now it becomes full blue, and it's running. Now, even though this light blue, dark blue thing is actually quite important as a developer to know a difference between, and something about starting up and what that means. So I'll come back to that in a moment, but let's just assume this is the first time we don't really know anything about that and we don't really care. So let's just be a bit messy and have some beers and have a little fun and then make some mistakes and then retrospect a bit about why these mistakes are there and what we can do about it and what it really means to run your application in a cluster, because everything is not just working all the time. So what we can do now is to go and say, So here I have the client. I can type kubectl get pods, and it can show me the pods are running. The client is the first one, hello swarm, and then there are two other things we're going to see it towards the end. So I can type kubectl. Look, this is not our OpenShift, so this is, I can type logs follow and type the client one, and there's tab completion even. This is the thing that tab. This is really nice with the tab completion, but installing that one can be a really pain. And if you don't know a lot about bashes and all this tab completion, how that works, you might. So I'm trying to not fuck up my bash. I had a trouble a couple of weeks ago because I had to upgrade the bash. Apple comes with a very old one, and this was a new computer. So I had to install that. It kind of causes my brew to fuck up as well and whatnot. So now I'm just happy that the tab completion works. So now we're following the log here, and it's supposed to call that service every 2 seconds. We can see it from here, and you can see this is not changing, and there's only one instance, and that's fine. So now I'm trying. I can actually try from this one, or I can try from. What is the command scale? Replicates 2, and then is hello swarm. What? Now I can't remember the. Okay, but from the command line, the intention was that you can actually scale up your applications. But actually, I've been starting using this one too much, so I just press a button. Now I'm scaling to 2. Oh, fuck, shit. Okay, so something goes up on the top. Don't look there. Of course, look there. I'm not trying to hide anything from you guys. But see now. Now there are 2 different names up here. And now we can play a guess game. Why did something fail and why did it fuck up? Okay, I'll tell you about that in a moment. But now, so we're calling 2 services. But what is the strategy? What's the logic behind these? Which one is called? There's only 2. Sorry?
Robin?
Round robin is a guess. Okay, let's look at that. 2. It's not round robin. What? No. Oh. Okay, so the story is that it used to be round robin. Then Google goes and actually look at the entire cluster and whatnot, what they're using it, and figures out that round robin is causing more problems than it solves because it gives a more predictable pattern. And it's actually, if you have sort of like this bridge thing where small changes can cause more and more waves, it's not so good. So it's actually random now. This is the best strategy I figured out. So yeah, even with 2. But this kind of spooks everybody because they look at it and this is 1, 2, 1, 2, 2, 1. What the fuck? Okay, so it's random. Anyway, the good thing is that the changes. If you're really unlucky, they call the same service 10 times in a row. And you think the scale didn't work. But why was there an exception to the begin with?
The warm-up didn't work?
The warm-up didn't work.
Or it wasn't successful before you actually made the first request?
Wow, I will give you a bit. Yes. So he paid attention. I talked about the light blue and the dark blue. So this is where things can go wrong. When you deploy something in the cluster, you have to consider your deployment or what your service is when it's ready. Because it's using Java or any other technology, it may need some sort of warm-up period. And only when it's really warm up and ready, you want to tell the cluster, okay, call me.
So when you actually scale, if you have already an instance running, it
it shuts down the instance and we put two of them.
No. So I had one instance running before I scaled up, right? And now I scaled it up to 2, and there was some exception, and now it seems to be working.
But the second instance should not receive connection only when it's ready.
Yes, that's exactly, that is the answer, that is. And this is the thing. In the cloud world, there's something called a readiness probe. So you should implement a readiness probe in all your applications if you're hosting service. And I did not do that. I was cheating. So let me just go here and find out why. I open my editor, and on the same time I go back to this here, and then there's a little up here that says, hello Swarm has containers without health checks. So this web console gives you sort of like a hint. You're running something without health checks. When I say health checks, it sort of like implies this readiness checks. But there's something else called liveness probes. Liveness probes and readiness probes are two things, a part of sort of common thing called health checks. So you get, there's a hint there. So I didn't have that. And why did I not have that? Because I was making a mistake on purpose for you guys. But it's also very important to know as a developer, this is a thing you need to understand, that you have to have these things in your application, because that is sort of like the contract you can say to the container or the container platform, is how the platform knows the state of your running applications. So it needs to two things. It needs to know when it's really ready, so it can start using it, and it needs to know if it's still running alive. And you can implement custom ways of these health checks. By default, it can do a HTTP call. Maybe you have a slash help or slash happy or something. It can do a TCP connection if that's in, or they can execute a script or something like that. But the most common ways is to use HTTP request, and with Java technologies, with Spring Boot and Wi-Fi Swarm and other things, you can very often include a HTTP embedded HTTP server out of the box, like we have here. I have here. Now, so to include that health check out of the box, it's very easy, because I am using the Fabricate Maven plugin, and I was really, really lazy. So I was just using an older version of the plugin that has a bug. That bug makes that there's no health checks out of the box. So just by upgrading, I get health check. Now, why do I get health checks then? This is because this Fabricate Maven plugin is able to detect what kind of product you are using in Maven. Okay, using Maven, this is Wi-Fi Swarm or Spring Boot or something else. Okay, if you're using them, and you have these dependencies on and whatnot, I can give you a convention with a standard health check out of the box. And it includes that in something called Kubernetes manifest files. So it sort of auto-create one for you. You can totally customize all that kind of things to your heart. But out of the box, the one that comes out of the box are fine. So I can just switch the version. And if I redeploy this one, it will work. So should we do that? Yeah, okay. Maven Fabricate deploy. I'm just considering sometimes it's nice to have something that is not working on purpose, so you can sort of keep on being evil. But let's just try to deploy this guy one more time. Now, this health check thing is only on one side. I have to say there can also be errors on the other side, the client that calls the service, even though if you run this in a clustered platform like Kubernetes or OpenShift. And this is we'll continue on doing that in a bit, being evil. So it's building and deploying. You can see this is some Docker push and whatnot, and all kind of things goes on. It should redeploy that without really the client changing as much. The only thing, if I'm not mistaken, is that it will actually scale it down to 1 again. You see here's the deployment going on. This one is now the new one coming up, and it actually has this light blue, but the light blue stays on for a because now it has health checks, so it's only when it's really ready. And I have to say, Java and Wildfire Swarm or Spring Boot, but Wildfire Swarm is more slower to start up, so it maybe take 5 seconds or 10 seconds to be really ready. So that's why the light blue is there. Now it's running. We have one, and the client works. So here it is. It's only one calling. And again, I apologize if I remember the command. I couldn't actually scale it up from the command line. But again, I'm just being very lazy. And now it should scale up without having any errors up here. You just wait a little while. And you can see it should probably start to picking up. Well, it's actually quite slow, right? Now that's the second one. Now, this was actually a challenge for me to demo a while back because I actually had a very old laptop, 5 years old. So, yeah, I had to do a lot of dance. So now it's running the two. Everything's a honky-donkey, but I also told you about that errors can happen on the client side of things. And also, the Kubernetes platform or OpenShift platform is sort of like a self-healing. So what happens is that the cluster sort of keep monitoring itself, and if something is not running as it's supposed to be, it's trying to mitigate that by spinning up new things. So it has this sort of, is what we call it, declarative state. So you tell it, okay, I want 3 instances of those, then you keep on monitoring that and start them up accordingly. Just trying to be, let's see if that works. Yes. So I was typed Docker PS. So Kubernetes and OpenShift is just Docker. So you can actually get the Docker client to look inside. So I'm listing all the process. I apologize a bit for the wrapping because Docker is very verbose, so it logs a lot of information. But what I want to see here is to find one of the pod that runs the swarm. Hystrix can be a little Hystrix, Docker Workers Turbine. What the hell? Where is it? Here's one. And then we have to find, here it is. It's probably a bit hard, but I wanted to show you if I'm doing the right thing, is I can kill a Docker process. So why I'm doing this? Because I'm a bit evil. I want to test resiliency and failovers and all that kind of things. But if I tell Kubernetes, okay, now I'm going to kill a pod, I'm going to shut down a pod or whatnot, do you think Kubernetes is stupid? No, it will just know, okay, you're going to kill that guy and just stop calling him. So everything just looks really working, right? So now I'm being evil, so I'm using the enemy of Google, Docker. No, they're good friends, but I'm trying to kill a pod without Kubernetes knowing it and see what happens. Now, if I type the right one, may or may not happen something. This is where it gets a bit more tricky. You can see here it's calling this one all the time, or it appears to be, but it seems like 5 or 6 times in a row. So this can be more tricky. Depending on what time you kill it, you can actually see the client fail, or that Kubernetes has actually detected there's a process that was died immediately and it stops calling it. So you have to be really timing-wise or hit the right spot. But you can see now the second one is up and starting again, and they're random between these two guys. But it's possible. I can also be really evil, kill them both at the same time. Then there's nobody running. Then Kubernetes says, no way, shit, nobody's running, and he wants to call me. What should I do? So, what's there? Yes. So, what one? Yes, the client side of things. Oh, it was really hard to. So let me just scale this down to 1, just to be, and then kill it, because I want to show you the client can fail. So again, Docker PS knows only one guy's running, so Kubernetes, we don't give him any chance on anymore. Oh, Docker PS. This is really hard. here it is, swarm, this guy probably, docker kill. Let's see. Nope. The client is kind of stuck at 35. The next call is sort of in a stuck mode. These things are harder to reproduce, but it's possible that when calling the service, the client can fail. And actually have a hard time reproducing that. Okay. So what I wanted to talk about a bit now is on how to build these kind of resilient service inside Kubernetes. That is, we tried to demo here. So errors can happen. One way for a client that is calling a service inside the cluster is that you can use retries. I try to call the client service, it fails, okay. Wait a little bit, I try to call it again, and so on and so on. That's one way of doing it. And because of Kubernetes, the platform is able to self-heal, so maybe there's a chance that a new pod spins up and it becomes ready, so when I call the service after a period of time, the service is up and running, and I get a response. In Camel, you can use this something called a non-exception, or multiple ways, but we're just saying if there's any kind of exception, try to retry up to 10 times and have a 1 second delay in between. That's one way of doing it. Now, there's a problem if you're using retries. It's called the thundering herd problem. Now, suppose that you have a downstream service that is used a lot by upstream service, and this service is under stress. You can't handle load, any other kind of things, you can't really scale it up again, or something like that, whatever it is. But if all the clients that call this service just get an error, and then they try to call you again, you don't give this client any chance to recover, because you're being an evil ass in that, and just keep calling them. Also, the second problem is that it prolongs the processing time of your request, because you just wait a bit, call again, wait a bit, call again, wait a bit, call again. Maybe that takes only 10 seconds to complete that transaction. That's not always the best thing to do. So in recent time, on these cloud platforms, there's a pattern became very popular called the circuit breaker. And it comes from the electricity world. So when there's a spike in voltage or something in your wirings, the circuit breaker can sort of detect that and kick in. It prevents those high voltage spikes to go through all your wirings and kill more electricity stuff. The same idea here in the cluster platform is to sort of be able to detect these errors and fail fast. So it has sort of like 3 stages you can go in. But this is where something can get a bit confusing, because green is good, that's success, you can drive and everything is good, that everybody knows that, and red is bad. So this works for people that are not colorblind. Then the problem is that it's a bit confusing with the terms. So green is good, but it says closed. I want to go to the bar, that's good, but it's closed. That's not so good. Anyway, it's a bit mixed there. Anyway, you just need to know the colors, and the closed is good. So what happens is that if calling downstream service after a period of time, so many fails of them, then it can trigger, and it goes to open stage, and then the subsequent calls are failing fast. But then it once in a while allows a few of these calls to go through and call the real downstream service, just to see, hey, are you okay now? And then if a number of these in a row is okay, then I say, okay, I think you're recovered. I am okay now. I go back to the closed state. So it's more a gentle way of doing that. But this only strategy comes with a price. You cannot use it for everything. For example, apologize, but I'll have to use the money transfer example. So I am transferring some dollars to you, and maybe that doesn't work. that's okay for me, but not for you. So in that situation, we need sort of acknowledgement and really confirmation that this downstream service worked. But this one is popular on sort of like web shops and other places where you can sort of use it, because to compose a web page today, there's a lot of service on between, sort of like recommendations and weather and things you can kind of see and top searches and whatnot. All these kind of services are maybe individual microservice. And then often they will call these real service and get sort of like based on user behavior. Are you from Australia? Are you male or female or whatever? It can kind of get a lot of information about you and show you top. But sometimes these don't work. And when they don't work, you can use an alternative fail fast mode and just sort of show a default thing or all Australian like beers or whatever it is. So, and there's actually a very good example from United Kingdom, UK. They have Sky Sports. You can go online if you're a subscriber, and you can see football games. And then you can imagine that some of these football games are really popular, so a lot of people go online to see them, and they get really angry if they cannot log in and see their football games. So what they did was to protect their login procedure with a circuit breaker. And then if that login failed somehow, they just said, yeah, you can log in. That means all the customers, when they had this problem, they could log in anyway and see the football game. Even so, if you're not a real Sky Sports subscriber, and if you knew the link to that login, you could also log in and see the game. But what are the chances people will know that, right? It's better to have happy customers and then have a few free rollers, right?
Free football games for Claus.
Yeah. True, just make it under stress, make it fail, right? And then I can see football. So in Camel, we implemented the most popular circuit breaker pattern called Netflix Hystrix. So in Camel route, you can specify a Hystrix, and then inside that, all that is there sort of protected by the circuit breaker. You can call a service, you can do more things what you want, but you can optionally include a fallback. The intention with the fallback is sort of like a computation. You can do like in-memory fast thing where you don't call auto service or not, sort of like an alternative they could use. Now you said, okay, don't call another service, but actually there's a fallback that allows you to call a second service. Sometimes you want that, but then you have to tell the Camel or the circuit breaker the fallback is actually also a potential problem. So you have to use on fallback via network. There's something called that. That allows the circuit breaker to execute the fallback. It's sort of like in a protected mode. It's called like a bulkhead, so running independently from the first one. So that's very important to use if you want to call a network call. Whereas this one is sort of like optimized in-memory thing, very fast mode kind of thing. Now, Hystrix allows you to get all this state of your circuit breakers in a web console, a Hystrix dashboard, so you can see them all. Kind of good thing. And I'm not sure if you have time, but if you have time, there's maybe a little demo. Oh, it's here. So let me just be really quick, because I have a client already built. So I'm starting the old client and starting a client that has Hystrix. So pre-build that client with Hystrix. And that's just one service here. Then I am clicking this link down here, which is the Hystrix dashboard. And I can click this button, monitor stream. And this may or may not work. Oh, something comes here, yeah. So now call Hello Swarm. So what this has detected is that there is one circuit breaker running in the cluster. It's fully dynamic, so if I implement other applications that are using circuit breakers, you will see multiple of them, and so on, right? That's the only one, and it's in use now. So there's like 5 requests per 10 seconds or something like that. It's green. You can see it's closed. Everything is good. So the intention is that we can, again, I'm just using scale it down. Let me see if the right one. Yes, so I'm scaling down this guy. And this guy that is calling the service, now the service is no longer, you can see up here, the circuit breaker becomes a bit unhappy. Now it's open. And if we go and look in the logs, oops, it's a new client. It's the Hystrix client. It says nobody want to talk to me. I should say nobody want to go to bar with me or whatever it is. So
what are the numbers on the different colors in the dashboard?
This one.
Yeah.
I think you have to work for Netflix to understand everything in the. Again, green, not green, bad. You can see the numbers up here. There are different ones, and there's some labels up here. Okay. Some of them are short circuit. That means when there's short circuit, it's actually using that fallback in Camel. And then you can also have a timeout. That's a different kind of thing. Sometimes they can actually detect that you call the service, it takes too long. Because one thing about Netflix Hystrix is it's optimized for Netflix. So that means it has a hell of a lot of options, and they are hell of a lot confusing. And they are very configurable, and they have a very low threshold. It works for Netflix. So the default timeout is 1 second. So you call a business transaction somewhere, better be quick. Now, of course, you can customize that in Camel. But where things get a little spooky is to all configure the right settings. It's also about the threshold it uses to detect, okay, there's a failure. When should the circuit breaker kicks in or not? If there's only one error, maybe that's okay for Netflix, but maybe not for you, and vice versa. After it has some errors for a period of time, how quickly should it be able to go back again? Again, there's many options. They're not, for beginners, they're very confusing, but a lot of people are using it, so you can find information on the net how to do that. So let's just try to start the pod again and see if this one recalls. Now it says 100% red. I think everybody kind of understands 100% and red, that's not so good. Unless you're colorblind. And also if you go and look a bit, then one thing that's actually quite interesting is you can make it work on the same time. So it actually was pretty quick. Now this one started to call again, and this one kicked over immediately. It doesn't always happen so fast, also because you saw I scaled it up. When it was really running, that Netflix circuit breaker may still fail sometime until it really, okay, now it's actually running for a period of time and I'm happy. So how quickly it sort of switched over depends on how you configured it. But this one was pretty quick. Okay, I think that's almost it. Oh yeah, this is pretty cool. As a developer, writing code, sometimes you need to debug. You can always do a system out print line and then run it again, system out print line. I've done that a lot. But there's also Java debugging. But how do I actually debug inside a Kubernetes cluster? It's not as easy as you may think. So one of the cool things is that the Fabricate plugin has a debug goal. And let's just be really, really, really fun and want to see that. So I just stop this guy and we stop the client. I'm not sure why this one is gray. And I go here, hello Swarm, and I say Maven Fabricate debug. I have the source code here. No, here. So here I want to set a breakpoint and I want to debug this code. When something calls me here, I want to debug that piece. Okay, I set the breakpoint here, and I run this Maven Fabricate debug. So what happens now is that the plugin will enable remote Java debug in the running Java pod, and necessarily restart it if it needs to do. This hopefully works. Now I was a bit unsure because it was gray, the circle there. I'm not sure why. Yes, now here it comes. It says this one is the one you're going to look at. Port forwarding to port 5005. That means that the plugin made it possible to do report forwarding from the running cluster to your host operating system, which is Mac OS, on port 5005 running on localhost. That means you should just use standard Java remote debugging as if it was running on localhost on port 5005, and then it forwards inside the cluster. So if I go in here, in my editor, this is just standard remote Java up there on localhost here, port 5005. Okay, so I should be able to click this button, and with some luck, it says connected to localhost 5005, and there's a check mark there. Awesome. And now I can go to the web page, this guy, and call this service from a web browser. And I say click, and now the debugger ends here. And if I'm really, what is it? F2. And then the computer is very clever. And now for the most important thing, some topics, what is under the iceberg. You can read it, the slides will be posted online and whatnot. There's many things to, for example, Ben talks a lot about stores. That is a topic by itself. Awesome talk, by the way. It's actually a very hard topic to understand all these kind of storage mechanisms running in that cluster. And especially many years ago, but it's very much more complicated, but still is today. So there's one thing, Istio. Does anybody know what that is? Oh, the cameraman knows it, so we don't need to know it. Okay, so just very quickly, the circuit breaker thing I've shown here was sort of using a library we embed together with our client application code using Hystrix. This is sort of like what we've been doing here with library, circuit breaker. This is our business logic running in the same service. This is not the best thing. This is some people call it microservice 1.0. They are sort of the idea of using something on the side for these circuit breaker kind of things. So when you call a service, you use something else that sort of deals that for you. So your business application is just your business logic. And this is the sidecar thing I talked a bit about. So you actually have two containers in the same pod. So your service, when you're going to call the service over here, ends up calling the sidecar, and the sidecar calls your service. And the sidecar has all kind of retries and whatnot. Now, there are two products for this on the Kubernetes platform, Lingard and Istio. Lingard was the earlier one, but this one is sort of, it's not out of the picture yet, but it will be probably because it's using Java, Scala code, boo, so it's very heavy. Lingard or Istio is the new thing. It's using Go, so it's very lightweight and nimble. But both of them are, good in some ways, but Istio is sort of winning. And on August 17, Christian Poster, who happens to work for Red Hat, he's giving a talk about service mesh and sidecars and so on. It's going to be recorded on YouTube as well, so it will be posted. You can see it afterwards and so on. You don't have to be online on that one. But this is a great guy to follow. He knows a lot more stuff than I do sometimes. Actually, he does, because he actually goes out to the field and talks to customers. I have to guess. They only let me out once in a while. Now they have put me all the way to the other side of the planet because Europe knows me. Some other good stuff that are free. Christian's book, another book for OpenShift. Actually, that is a good book, if also for Kubernetes guys. But and if you are into DevOps things, there's also a good book there. They're all free. People love that. Now, find your credit card. Because, unfortunately, I have to make a living as well. So, no, my book is not so free, but I can offer a discount code. There's one called Red Hat Camel. gives you 40%. Now, I have this one expires this month in September, or next month actually, so you still have time. But I have a permanent card that is called Camel 39, but that is 39%. It's not as good as this one. Okay, so Camel 39, that's best I can. So, yes, the publisher is not very intelligent. So sometimes they have given promotion for 50%, and guess what the coupon code was? Camel 50. So sometimes they make a mistake and leave something open. So try these combination of 99, 98, and 200 maybe. Okay, that's it. The computer told me to shut up, so I will shut up now. Any questions, or let's go for downstairs for.
Any questions?
I'll ask you later.
Okay, good. Okay, end of recording.